Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, great. So hi, my name is Eitan Dar. Thank you, everyone. I am at the University of Washington. I'm going to be talking a little bit about the Vinegar project. Vinegar, the name comes from a incident that we noticed in China, which was during the SARS outbreak. A little province basically had all the people in it. With SARS attacking this province, basically all the people in the province started buying out white vinegar as a cure for the SARS epidemic long before Beijing even noticed that it was impacting the country. And so our idea is to extend this a little bit into a slightly larger domain. And our goal here is to identify and use leading indicators of internet use as indicators of outcomes. So outcomes can be anything. They can be sales, they can be other kinds of internet use. And mostly what we're going to be concerned with is the consumption and production of digital information as an outcome. So can we predict what's going to be happening on the web or on the internet based on what people are doing? So I'm going to just jump into this. This is a presentation that I did at the World Wide Web conference this year. I apologize to those that have already seen it. The jokes don't get any funnier. But let me just jump into this. And I'll also talk a little bit at the end about a separate project also using this data that we did at UW. So hopefully I don't need to do too much convincing about why it's important to be able to predict things. We want to be able to figure out which ads to buy. Can we predict the response to a TV event? What kind of news events are people responding to? And ideally, we'd like to integrate other forms of behavioral data, so not just things that people are doing on the internet, but things people are buying, things like brand awareness, etc. But initially, we're going to be concerned with the internet domain. So basically, the things that we're trying to do is figure out the usual who, what, when, where, why, and how of prediction. So can we correlate different kinds of behavior that are going on? And the thing to remember as I go through this is that we're treating attention as a resource. So basically, people are investing in their time, and we would like to consider that in making predictions as an indicator for other kinds of investment, whether they be more time investments or potentially in money or, excuse me, or in other forms. Sorry, I'm losing my voice a little bit. The thing that I'd like to reiterate here is that we are considering internet use as an indicator for things. And there's a term that I use, which is information side effects. And basically, what this means to me is that as people are doing things like searching on the internet, mentioning something in their blogs, reading news, or voting on other forms of media, a side effect of that is we can use that as a proxy for learning what people are interested in, what people care about. And the first issue that we're going to address with this project is going from these forms of data into something like time series data. The reason we want to do that is because there's lots of smart people who have worked on ways of taking time series data and going up to today and making predictions going into the future. And whether that's visits per day to a website, or Seattle rainfall, or other things. I said the jokes weren't going to be funny the second time. The other thing that we can do with time series data is look at the correlation between two different time series. So, for example, we can look at blog posts about a news topic and also searches about that news topic, and we can draw some correlations and find that there are leading indicators in potentially the blog stream that are going to indicate peaks in the search stream. The thing that I want to emphasize in this is that we're primarily concerned with predictive and correlated. So there's some external event that's happening, and that's triggering a response in both the search domain and the blog domain. And what we're going to try to do is correlate them and find things where one response is a leading indicator for another. This is to differentiate from something like this, where sunshine presumably impacts suntan lotion sales. And this is a different instance where one event is causing a response and another response after that. So these are causal and predictive. And we're not going to try and make too many causal arguments unless we know something about, we have some prior knowledge about the system. So this is the kind of the description of the rest of the talk. Basically, we're going to be talking a little bit about how to transform text and behavioral data to a more useful form, so the time series data. Once we have that, and we've captured that from a number of different places, what kind of analysis and visualization can we provide to users, to analysts, so that they can actually do something? And I'm going to be talking about some observations, things that we've seen as a result of this analysis. This is kind of a representative diagram of our system where we're going from unstructured data to time series and doing some model building. And then we have some analysis algorithms that we're working on. And ideally, at the end, we'll have some predictions, although I'm going to be concentrating kind of on the top chunk of this. So this is how we start with the data. We basically take the Microsoft logs as well as the AOL logs, which happened to also be from the same time period, May of 2006, luckily for us, I guess. And what we're basically going to do is count the number of instances of certain kinds of keywords and bucket those into, say, 10-minute chunks. Okay, so every time somebody makes a query like Iraq War, we're going to count that. And from that, we have a histogram, and from that, we can go to a time series. The thing that we need to do is do a little bit of normalization. So one thing we can do is look at the number of total queries done in that period. We can also look at maximums for this particular query or for all queries and do some additional normalization. We call this a query event stream. So this is the query event stream for Iraq War for the time period of interest, so May of 2006. We do something similar for blog posts. We have about 14 million blog posts from 3 million bloggers also around this time period. And every time somebody mentions a certain phrase like Iraq War, we can count that. For news, we were only able to capture news after the fact, so a lot of news goes away, unfortunately, after 7 days. The press doesn't allow people to crawl their archives. So I'll come back to this into something that a want for later, I guess. Basically, we were only able to get about 13,000 articles from the CNN, BBC, and from those, we were somewhat able to extrapolate interest by looking at inlinks and other things to kind of get a sense of what the interest was in a particular news story. And the last interesting piece of data is this great resource called TV.com, where people go in and vote on TV shows. So from that, we were somewhat able to extrapolate viewership for a particular TV show. So we were looking for certain phrases from about 2,500 TV shows that were aired in May of 2006, and again, generating this time series data. So clearly, we don't want to just be working with specific phrases. What ideally we'd like to be able to do is go to topics. So things like Spears Britney and Britney Spears should all be merged into one thing. So we do a pretty naive algorithm. We look, thanks to Brian and Lada, we were able to reissue the queries against the search engine, against Microsoft's search engine, and find the result pages, and then using that, we were able to recluster search pages. So queries that returned similar sets of things, and the clicks were similar, and there was some textual similarity. We were able to infer that those queries were related. So we were able to group query event streams into topic event streams. So this isn't important quite yet, but just to bring this up right now, for some of the discussion later on, the experimental set that we used is about 3,600 of the most frequent queries from the Microsoft logs. And then we would look for the corresponding query events, the corresponding topic event streams in all these other sources. So you'll note that most things that were queried for in Microsoft were also queried for in the AOL data sets. But there are slightly diminishing instances of the topic event streams in the other data sources. So now that we have these time series, what can we actually do with them? So the first thing that we did was we built this thing called the Explorer, which lets us issue a query into the system, which is something that we're interested in. So in this case, I queried for Lost, which is a popular US TV show. And what you're seeing here are peaks corresponding to the airings of the TV show. So once a week, you'll see a peak. The red line represents AOL, and the blue line represents Microsoft queries for that topic. What we also generate is this list of related terms. So while the initial query was lost, as you see at the top of the screen, you also get other things like Flight 815 and the sequence of numbers, which are related to the show, but are not, don't mention the word lost in them. So the algorithm seems to do the right thing in terms of generating other query event streams that are going to be related. What we also support then is sorting by similarity of the query event stream to the original query, to Lost. Can sort by instances. And the last thing is kind of neat. We can sort by the correlation of the query event stream of each of these queries, of each of these phrases, to the original Lost term. So you can see similar behavior in a lot of the other query event streams. Now, we don't do a perfect job always, so what we let the users do is actually check on or off certain query event streams in the analysis, and the analysis kind of changes dynamically based on whether you want to include a specific query in the analysis. And there's always the correlation being returned, which tells you the maximum correlation and what the delay is, so kind of what the best shift is to get the two curves to align. So while a lot of things like Lost, the peaks correlate at 0. Okay, the maximum correlation is at 0, so no shift is necessary. There are lots of other instances where actually 60% of the data, the correlations are not at 0. So there's some shift that's necessary in order to bring things to maximum alignment. What we started noticing was that this kind of visualization that we were displaying to the user was really making it difficult to notice some differences that we wanted to allow the users to visually explore. So all these curves have the same correlations, but they clearly have very different shapes. So while it's easy in these kinds of instances to see the difference quite easily just by looking at it, you have much more complicated curves. And how do we compare them? Is it possible to provide a visual summary of the differences? One thing we can think about doing is just taking magnitude differences. This is a very trivial kind of thing to do. But what we started thinking about are other ways of doing this. So we don't want to just capture the delay, the differences between the two curves, so magnitude differences. What we actually want to model is changes in behavior of the different curves. So each of these curves has inflection points. And what we'd like to do is map points that are rising, points that are peaking, falling, and run, and be able to map those. So what we use is a dynamic time warping algorithm, which is described quite extensively in the paper. It's a manipulated dynamic time warping algorithm, and it works quite well. And so what we have at the end is basically the ability to map these points from the two curves. And so we provide that for the users within the visualization. The next thing that we started noticing was that what we were doing was drawing lots of lines on the display, and this wasn't very visually appealing. So we started thinking about ways of summarizing differences between the two curves. And what we came up with is something called the dynamic time warp radar. Basically, what we'll do is set one curve, in this case the green curve, at the bottom as the reference curve, and then we will draw this set of axes where the x-axis represents lead and lag behavior, and the y-axis represents magnitude changes. And what we will do is essentially move the set of axes along the reference curves and pull out each of the warp paths, each of the lines, and map that onto the display. So what you get is something that looks like this, and this is a visual summary of the difference between the two curves. We also draw the centroid, and what this is telling us is that curve 1 has a bigger response on average against the reference curve, and that it lags on average. So if the point is on that side, it lags. If it's on this side, on average, it leads. So here's a quick test. What would the radar look like for this curve? It looks something like this, and what we can see from this is that pretty much all the behaviors in curve 1 are leading in both magnitude and time against the reference curve. So this is what it looks like within the visualization. We provide this for the user making the query. This is from a different TV show. This is Prison Break, another popular TV show. And what you can see, hopefully, is that this is queries and blogs. And what you can see is that queries are leading both in magnitude and generally in lead and lag behavior until pretty much the end of the season. So this is when the TV show goes off. And people no longer query for things like, when is my TV show on, but instead start discussing they start discussing kind of the next season on the blogs. And so you see these 2 points kind of at the bottom that represent this. And this is kind of an interesting display, we think, for understanding the difference between the two curves. So the other things that we can do is actually build some radar variants. We can weight towards things that are more recent. So points that are more recent can be darker. We can also color by the direction of the curve. And the other thing that we did is build this radar search tool where we aggregate all the centroids from all the different topic event streams. So we fix, say, Microsoft, the Microsoft data, the query data in the center as the reference, and plot out all the other centroids against some other data set. So each point represents, for example, the blog centroid of a specific topic. And what we let the user do is select out a region of interest. So they can basically ask which topics do bloggers lead in, which topics do bloggers lag in different kinds of contexts. So let me just talk a little bit about some of the things that we actually started seeing with the data once we started doing the analysis. We randomly selected some of the 3,600, and we manually went in and labeled them by topic and kind of did some analysis. And the question that we're trying to ask is, why do we search or blog or react to news? So here are some things that we found. There's more in the paper if you're interested. Some of these might be obvious to you, some maybe not. So here's a couple of things that we noticed. Bloggers react to weird stories. Okay, so they tend to lead in behavior when it comes to things that I call news of the weird. These aren't necessarily weird stories. They may just not be front page news. Okay, Igor Vokovinsky was a 7'8" man, I believe, who started. Somebody gave him size 26 shoes. Like this German cobbler came and built him these custom set of shoes. And the bloggers found this fascinating. So they had this behavior of blogging about it way before people were actually searching about it. The USS Oriskany, a ship decommissioned by the U.S. Navy, and it was decommissioned by sinking. It wasn't really front page news. The bloggers found this very interesting, and so they started blogging about it way before people actually started searching for it. In contrast to this, people, when there are anticipated events, so things that people know about in advance, like the Preakness horse race, tend to be searched on before they're blogged about. Bloggers like to talk about things that are new. So unless there's something new to report, they're not going to talk about it. So people search for when is the horse race, which horses are involved, and bloggers will not pick up on this until there's actually something to report. So the event has actually happened, and we have something new to say. Same thing happens for TV shows. There's a lot of leading behavior in search where people are searching for what time is the TV show, for example, and bloggers will not actually say anything about it till it actually happens. Another instance of this, I call this familiarity breeds contempt. The hypothesis behind this is that we get tired of certain kinds of news, and it basically takes something really exciting for us to react. So while the Enron trial, you can see, was in the news most of the days of May, it's not until an actual decision was made that we see search behavior. So pretty much nobody searches about Enron, nobody cares until there's something new to talk about. Okay. So this is another hypothesis. It's possible that AOL users care about care more about Mother's Day. So this is something that we saw. There were more searches on AOL for Mother's Day. And it may have something to do with the demographics. But the hypothesis is that what's on the front page of the search engine is actually driving search. So whatever the portal has decided to present to the users is actually manipulating them in some way. Again, this is a hypothesis. We don't actually have the front page from these different stories. But what we see is that people are reacting to news stories differently. And our conjecture is that whatever the search engine has chosen to present to them on the front page is actually causing them to search for certain things. So the hypothesis, again, is that basically different portals encourage different kinds of searches by presenting different information on the front page. Just briefly, there's a lot of related work. And again, you can look through the paper. So some people have attempted to correlate blogging behavior to sales rank behavior on Amazon. There are people who have looked at moods in blogs, trying to extrapolate that from time series data. And again, I encourage you to look at the paper for more about this. I'm not going to talk too much about this. We're considering lots of extensions. The main thing that we'd really like to do is actually make predictions. So a lot of the tools that we've built are things to allow us to take text into time series and then do some visualization and analysis. So providing tools for users to actually try different kinds of things. What we're hoping to do is actually let users make predictions. So given some topic, can I predict a spike? Okay. So that comes down to folding some of the prior research on time series analysis. We don't necessarily have anything new to contribute there, but we think that a lot of the prior work may be usable in this context. The other thing we'd like to do is be able to compare different topics. So can we compare topic event stream about Bush to the topic event stream about the Iraq War, or Britney Spears and Paris Hilton, or whatever you might choose to compare? Are there things that are indicating from one topic against the other? So just briefly to summarize, the thing that we built as this kind of first result of the data is a mechanism to convert a number of different unstructured sources, structured and unstructured sources, into time series. We built this explorer and this kind of visualization system called the radar. And we found a number of things. And again, I really encourage you to look at the paper because I think there's a lot more in the paper about this. So let me jump quite drastically away from Vinegar just to briefly plug code search, which was something built by Raphael Hoffman at UW. And Raphael wanted to build a better code search engine, so kind of like Google Code Search or Krugel, for those of you that have seen these things. So Raphael basically used the data set in a kind of clever way. He looked through the query logs for things that people were actually querying about when it comes to code. So he would look for things like Java and specific instances. So Java, the query Java augmented with other things. And what he found was this kind of distribution of what people were searching for. He found manually annotated. So he did actually a lot of work. Found that a lot of searches were for APIs and some were for troubleshooting. And using this, he was able to construct a very effective system, which is being published at WIST this coming fall. And it actually seems to work quite well. It provides all these features for users to do search. So it's kind of neat because he was actually able to use the search data to get an insight into what people were looking for, and from that, build a very effective system. So just to wrap up, the good, the bad, and the wanted. The good, first, thank you. The data set has been wonderful. The access it provided us was invaluable. Like the things that we could do with this data, we wouldn't have been able to do otherwise. The API key was also extremely useful, so thanks for that. I don't have too much bad to say. There's things that we couldn't do, and that's more of a wanted thing. So in particular, in presenting some of the results at www, people were asking us questions about sampling methodology, where the data was coming from, was it only English US, things like that. And it would be very useful to know that in advance so that we can answer those questions. It would also have been useful to know this information of when the data was coming from, and things like that in advance. Some of the other forms of data that we wanted to gather, like news, needed to be searched for and crawled at the same time as the data was going to be coming. So we would have needed to know in April to crawl for news in May so that we could do this kind of analysis that we wanted to do. The other thing that we had to do, and this worked well because a bunch of us gathered together and basically recrawled for the search engine result pages for the queries, but it would have been nice to actually get the search engine result pages for that particular time. And I guess that's pretty much it. I guess I have a couple minutes for questions.
So I got a question regarding how you said bloggers don't talk about. Okay. Sorry, I got a question about how you said the bloggers they didn't write about things that haven't happened, and you used horse race, the Preakness horse race, as an example. Do you find that that's more topic specific? So, sorry to use this here, but as an example, the Apple iPhone, right? So that just recently came out, and there was a lot of talk when speculating about what could be included in the actual release.
I think that's true. I think there were unknowns, and people were making guesses about that. When it comes to things like the horse race, it's known, right? There's a set of facts that are known in advance of when the horse race is going to be happening, and people care about those, but they don't necessarily care to discuss them that much. Okay, so I know that the TV show is going to appear on Friday, and I know who's going to be in it, so I'm not going to blog about it. I don't know much about the iPhone yet, so I'm going to speculate and make guesses. So I agree. I think it is topic dependent.
Yeah, I'm just curious, Eitan, hear you speculate on, should you be able to do predictions well in advance? What are some interesting applications you have in mind?
So I did that a little bit in the beginning. I think it would be interesting in terms of advertising, for example. Frankly, I'm interested just in understanding behavior, so in large scientific understanding of behaviors on the internet. But I do think that it has application in brand targeting, brand awareness, for example. Like, we want to understand when something is mentioned on TV, is there any impact on search behavior, on blogging behavior. We may want to be able to buy AdWords based on what people are blogging about. So if we can predict that certain things that are being blogged about are going to cause spikes, we may want to buy AdWords.
And Microsoft, for example, might be able to sell futures options on ad space.
Sure.
Yeah.
Can I please ask you to identify yourself, just so that everybody starts putting name on faces?
I am Anindo Ghosh. I was just curious, how are you planning to, or how you've done trying to separate correlations from causal inferences? Can you briefly?
Well, so I don't want to make causal arguments because I don't know. Right? There's plenty of things that are causal that are just too hard to detect. There's some literature on basically doing that, but we concentrate mostly on correlations. Okay, so we do believe that there is some external event that is causally causing a response in the two different analysis, two different domains that we're looking at a time. But we don't care what that is, I guess. So we pick specific topics that we know are going to, so we only do analysis on a specific topic. So we look at a specific topic within the blog domain and a specific topic in the search domain, for example. We don't pick two arbitrary topics and start doing n-squared correlations, trying to find things that could look the same. Because then you start finding things like the Bangladeshi butter production predicts stock, the stock market. So.
Yes, Alistair Moffat from Australia. There was a joke made a minute ago about futures on AdWords, but obviously you can take time series data from actual stock prices and regard each of those company names as a query so that you've got one perfect time series that matches the name of the company, Procter & Gamble or Microsoft or Dell or something, and then see whether blogging predicts what's going to happen to the stock price, and then you can stop thinking about anything else.
Right. Yes. In some way, yes. I think that might be possible. Realistically, I don't think those things work, especially for stock prediction. There's so many people trying to do these things. Ken, you disagree?
No, actually, I do agree. And years ago, I saw a paper out of Hong Kong University of Science and Technology that showed a very nice correlation between stock market prices and mentions in the popular news. The only problem was the news was a lagging indicator. They would tell you what happened. And so lagging indicators are actually rather easy to come by.
Yes. I think that, for stock in particular, that's been leveraged in so many different ways that I think it's just difficult to find really good discussions within blogs, like somebody who actually knows something that's going to if it gets buzz, I don't know. Maybe. Is that true? Like, did people react to the iPhone bloggers and buy more Apple stock, or did they wait till the product actually came out? I don't know.
It depends on what they actually announce, I guess.
Yeah.
One thing that I can think of is as soon as they announce the iPhone isn't 3G capable, for example, I think that was mentioned on a lot of blogs.
Right. But did that, yeah.